I have implemented 6 different reflectance models such as Phong, Blinn-Phong, 2 non-photorealistic techniques such as Toon and Gooch, and 2 photorealistic techniques such as Minnaert and Oren. I have used 2 simple 3D models, a teapot on the top and a sphere on the bottom. Furthermore, the different reflectance models can be changed using the following keys displayed on the bottom left. To change the various uniform parameters in the fragment shader, I have made use of the IMGUI library available. I have also added parameters such as ambient, diffuse, and specular color, and the light's direction. These values are specified in a way to display the appropriate changes in the model. The light shines from the middle right. I would be varying the light's direction to show the darker sides of the material in the different models. Starting off with the Phong model, which is the most basic reflectance model, on top of which other reflectance models are created. It is a combination of ambient, diffuse, and specular light. Ambient light determines the light which exists in the scene. Diffuse light is reflected from the surface in all directions. This component depends on the surface's normal and light direction. And the specular light is a light which is reflected in a shiny manner. This value depends on the viewer's position and the reflection direction. We can vary the shininess parameter for the material. We can control the amount of specularity. So reducing the shininess makes the light more spread out, as it can be seen, and increasing makes the shininess component more concentrated at a single spot. So as it can be seen in the model over here, it is more concentrated for a higher value of shininess, which is 250, and as we reduce the value, it starts to increase the area. So if I move it down to 12, you can see that the specularity area increases. So I have also implemented the Blinn-Phong model, which uses the same calculation for the ambient and diffuse lighting, but in the specular lighting, instead of the reflection, the light's direction and the viewer's direction are taken into consideration. This is a more efficient way to calculate specular highlights to create a realistic representation of the object's surface appearance. So on enabling the Blinn, we can see that the specularity is now more spread out compared to the Phong model for the same shininess. And as I go on increasing the shininess, it is also decreasing and concentrating on a single point. We can notice that the texture has now grooves in it, unlike the Phong model where it is very smooth. So similarly for the Blinn model, we can see as we go on increasing, the specularity spreads out, and as we increase the value of the shininess, it concentrates on a single point. So moving on to the non-photorealistic techniques, in the Toon model we can increase or decrease the number of layers based on the intensity of the light. This intensity is calculated using the light's direction and the normal. Based on these varying intensity values, we can segregate the layers by giving them different color values. So the default layers I have set to is 5. So we can see the first one is a light green, then it's a darker shade of the green, and a much darker shade, and then completely black. So as I go on decreasing the number of layers, if I decrease it to 1, we can see that's a single layer, which is green, and then 2 is green and black. Similarly for 3, 4, 5, and 6. So I will also vary the light's direction to give you a gist of how it looks for other materials view. So this is how it looks like. Now in the Z direction. Next, in the Gooch model, we can specify the surface, warmness, coolness color and the diffusion amount for the warm and the cool. This works on creating a silhouette of the object by separating the object into warm, which is the highlight, and the cool, which is the shadow. The resulting pixel is determined by the combination of the object's color, the warm color, and the cool color specified. So in the Gooch model, we can change 5 parameters with 3 relating to the material's color. First is the surface color. I will just decrease the value of red. We can see that the surface color of the material is changing. I will turn it back to 1 now. And next is the warm color. The warm color is for the highlights. So if we change the color to red, we can see that it's changing on the highlights. As I increase all to 1, we can see that it becomes more brighter and the color changes. And next is the cool color, which is the shadows. So on changing this, we can see the background changes. If I keep it all to 0, it will turn to black. And if I keep all to 1, it will turn into white. So as we increase the value of the diffuse warm, we can see that the highlights from where the light is being pointed gets brighter. So when I increase this value, we can see that the highlights are becoming brighter and brighter. And on reducing it, we can see that it becomes a smaller highlight and becomes a bit darker. And for the diffuse cool, on reducing the value to -1, we can see that the shadows are very dark right now. So I'm going to increase the value, and as we increase it, we can see that the shadows have also now become a whitish color. I will decrease the cool color so it can be seen. And now as we reduce the value, it becomes darker, and increasing the value makes it lighter. So I will just change the light's direction so it can be viewed easily. So this is for the warm, which is the highlight, and this is for the cool color, which is the shadow which is falling. So right now the light is in this direction. So this is the shadow and this is the highlight. Now moving on to the photorealistic techniques. Firstly, the Minnaert model, which is made on top of the Phong model, wherein it calculates the intensity of the light using the normal, light, and the viewer's direction. In this, a darkness coefficient can be changed, and decreasing the value increases the object's brightness, giving it a glowing effect, and on increasing the value of the darkening coefficient, the object becomes darker, making it look dull. So in this Minnaert model, we can change the material shininess, and we can also turn on the blinn, and we can also change the darkness coefficient. A lower value makes the shadows or the parts which are away from the light brighter, and a higher value makes the shadows darker. So as you can see, I'm going to increase the darkness coefficient. The model has now become a bit darker, and now I'll be reducing this value. We can see that now it starts to increase at the highlights, which is where the light is coming from. So this is at completely decreasing the value to -2. I can also increase the material shininess, and also turn on the blinn for the Minnaert model. I will change the light's direction to make it more visible of the brighter side. So this is at decreasing the darken coefficient, making it darker, and decreasing the material shininess and increasing it. Lastly, the Cook-Torrance shader simulates light interaction with rough surfaces. This shader considers the surface material, incoming light, and the viewer's position to affect the specular reflection of the light. The specular reflection uses a Fresnel term that describes the amount of light reflected from the surface. The Cook-Torrance shader also takes in a roughness parameter, where a low roughness value indicates a smooth surface with a high amount of specular reflection. In contrast, a high roughness value indicates a rough surface with a low amount of specular reflection and a high amount of diffuse reflection. So, as we increase the roughness value, the specular light spreads throughout the object, making it look rough. And as we decrease the roughness parameter, the material looks very smooth with a high specular reflection. Next, the K parameter controls the amount of specular light that is being passed. If we shift the weight to 0, the object appears to be black, leaving just the specular reflection. And as we increase the weight of K, the specular component becomes brighter. Lastly, the Fresnel parameter varies the size of the specular reflection. As we decrease this value, the specular reflection becomes smaller and smaller. And on increasing the value, the reflection becomes larger.